started everything IoT 3 years ago, we identified 4 sectors that have huge opportunities and potential in Australia in general, but in Australia in particular. And they are agriculture technologies, smart cities and transport, energy and resources, and healthcare and well-being. And last year we ran a few smaller forums, very specific on some of those areas. However, we actually we had a very busy year last year. We had 3 small events and 1 summit, so we ran out of time. And unfortunately, we were not able to hold the healthcare and well-being forum. So I was looking forward to actually include it in the summit this year, because I think this is one of the biggest area that IoT connectivity is going to change our lives. So I'm very happy that we'll be able to bring really thought leaders in the space together. And I would like to introduce the chairman and moderator of this session. And thank you, Ashley, for the last minute, willingness to do this for us. So Mr. Ashley Brinson is the Executive Director of the Warren Center for Advanced Engineering. Ashley has a broad experience across the technology and innovation spectrum and over 25 years in the industry. An inventor of 5 PCT patent sets, he has extensive experience in silicon and silicons, having designed, built, and managed major facilities in the US, UK, and China. Ashley holds a BCHE from Georgia Tech and an MBA from Rutgers and a Juris Doctor at Sydney University Law School. Ashley is a Fellow of Engineers Australia, a Fellow of IC CHEM-E, and a lawyer in the Supreme Court of New South Wales. Please help me welcome Ashley.
Thank you. The Warren Center is a center of the University of Sydney. We promote innovation because we think innovation is cool. And the coolest part of innovation to me is the power of technology and innovation to make us healthier and better. So although there wasn't time for the session last year, I'm very pleased to moderate this session. IP Australia a couple of years ago ran a report and noted that in Australia there is a relative specialization in the technologies that come forward in medical devices and healthcare technology. And so I think this is a special place to be innovating. Our first speaker today is Professor Jacob Rosen. Jacob is at the Department of Surgery and the Department of Bioengineering at UCLA in California. He's a graduate of Tel Aviv University with a couple of engineering degrees there. He's developed an upper and lower limb exoskeleton and the ExoUL7, and I'll bet there are photographs in his presentation of this. He's got 2 books on medical robotics. Please welcome Professor Jacob Rosen.
So this is 7 of 9. It's sort of disclosing how old I am. But this is my childhood wet dream. And she represents in many respects the best synergy between a human and a machine. And we are in an age and time where we are very close to what she represents in science fiction. So I will present the problem first, and I'll show one aspect of a solution to, which is relating to my work. But I will start very broadly and ask what is the agenda of humankind. So ever since we emerged from Southeast Africa as an individual species, we were worried about hunger. So hunger is still a problem in the world, but it's not a part of our agenda. more people are dying from obesity even in third world countries than hunger. So I'm not dismissing the problem, but I'm saying that it's not humanity on the humanity agenda anymore. Infectious disease used to be, as I mentioned before, in Europe, at some point, half of the population was destroyed as a result of infectious disease. The CDC obviously will not tell you that this is over, but we haven't seen any outbreak ever since. And so, again, it used to be, but not anymore. War, since World War II, we still have outbreaks of conflicts, but it's unlikely that one country will invade the other and the world will just stand still. So again, it's not part of our agenda. The question is, what is our agenda? So one thing is health. We care about us extending our life significantly, and there is a claim that our grandchildren will be able to extend their life as long as they want. It doesn't mean that if someone will shoot them, they won't die, but through regeneration of tissues, we can essentially live as long as we wish. Happiness, surprisingly, many of us are fascinated by this concept, but from the DNA perspective, we are not destined to be happy. So therefore, it's something that we are imposing on our life to some extent, successfully, building ourselves together all over again. So if we miss a limb or miss vital organ, we have now tools to replace them. And to some extent, my talk will be related to this aspect of the humanities agenda. So I want to introduce you a disease. This disease is called stroke, and primarily it's an assault on our central nervous system. The brain represents about 2% of our body mass, but it consumes 20% of the oxygen. So it is a very hungry organ for oxygen, and once we disrupt the supply of this oxygen to the brain would die. As any good plumbing problem, supplying blood may be, or disruption of supplying blood may be through some clot in the pipes. 85% of the stroke would relate to this problem. And the other problem, as in plumbing, it's a leak. 23% of the cases, blood will start leaking between the skull and the brain, creating pressure on the brain. What will result in both of these two scenarios is a death of part of the brain, and with that death of cells, all the functions related to that part of the brain will die as well. So this represents the major cause of long-term disability in the US. This is why people seek services. 95 of the patients are 45 and older, so most of the people in this crowd are candidates. Every 45 seconds in the US, someone will experience a stroke. This would translate to 800,000 cases a year and 9 million cases worldwide in the US. This will add to 7 million cases in the US and 30 million worldwide. So what typically would happen in stroke is half of the body will be paralyzed. The rehabilitation process may recover some of the gait cycle, but 85% of the people will suffer from disability in their arms and hands in such a way that they will not be able to hold a cup of coffee and drink again. And as time goes on, this disability leads to neglect, so pretty much people neglect half of their body. This is a diagram that shows how much time the insurance companies are allowing you to recover from stroke. So this is how much time it takes a baby to be grown up and fully functional from the motor perspective. It's almost 18 years. Only 3 months is dedicated to recovery from stroke. And so in these 3 months, after stroke, you are brought back to a baby stage in terms of your motor skill. You are expected in 3 months to learn what you have done in 18 years. The common practice of stroke is, I called it 101, meaning that there is a therapist that is manipulating your body and in some hope that a recovery process will happen. But the limiting factor is a therapist. The brain has this capacity called neuroplasticity. It can reconnect itself as a result of training, but with a single person treating you, this capacity is limited by the therapist and not by the patient. So we want to change this dynamics, and we can change it through the introduction of robotic systems. This is a quote that was delivered to me in closed doors. It's pretty much saying, we don't know what we are doing and we don't know what to do. Most of the neurologists and the therapists won't admit it in public, but this is what they say in closed doors. It's a testament for the fact that we don't know exactly how the brain functions, and we have challenges recovering if it's affected. So the whole therapy is based on a term called brain plasticity. Brain plasticity is the ability of the brain to reconnect itself. So after a stroke, when part of the body is, or part of the brain is damaged, the brain can build new connections in itself, but it's doing it as a result of triggers, and the triggers are typically external. So I need to manipulate you, or something else needs to manipulate you, or with you, and as a result of that process, the brain will reconnect itself. As you may know, the left hemisphere is controlling the right side of the body and vice versa. But there are many interesting coupling between the two hemispheres, and I can demonstrate it in a very simple experiment. You should do it if you're sitting in front of a table. Take your 2 fingers, put them on the table, and try to rotate your 2 fingers clockwise, okay? So rotate them clockwise, and as you do that, keep increasing the speed faster and faster. At one point, some of you have experienced it, one finger switched to the other side and you started to do this. If you haven't done that, then it's because you're not fast enough. If you keep increasing the speed, at one point, one finger will switch. And the reason is the brain is sending to both sides of the body the same command, okay? The reason why I can move only one arm is because the brain would suppress that side, but it doesn't mean that it didn't send these signals. So the fundamental way of moving is symmetric mirror image way. And so this is what I'll show you a video clip, it's 5 minutes long, and it will describe the process of therapy using robotic devices and this mirror image idea. It has a audio, so I hope it's connected.
I did have a stroke, but it was 12 years ago. After the stroke, it had affected my shoulder and my arm, my right leg.
In the biomagnetic imaging lab at UC San Francisco, Fred is helping scientists test the robotic exoskeleton arms. Small sensors in the robotic arms monitor Fred's movements and communicate them to a virtual world that he watches on a screen. The robot guides and supports Fred's stroke-affected arm based on the position of his healthy arm. A physical therapist offers advice and support as Fred completes several virtual reality games. The therapeutic robot system was built by computer engineer Jacob Rosen and his team on the UC Santa Cruz campus, about 80 miles south of the San Francisco testing location.
The exoskeleton that we developed has 7 degrees of freedom with 3 joints, meaning that it can support any movement of the human arm.
This means the arms can reach 95% of the typical human range of motion.
Other systems don't provide this much of flexibility in moving and supporting all the joints. Furthermore, we have 2 arms. And what is unique to the treatment that we are studying is dual arm treatment, meaning that the patient is wearing these 2 arms and they are using the healthy arm to drive the disabled arm, which is quite unique to our system, and it's very beneficial for the recovery as well.
So the unaffected arm clearly helps you part of the process. You can certainly tell that. So there are a couple things going on, and not just a robot, which would help you, I think, intuitively help the process. But the fact that it wasn't doing things bilateral, I think that was probably a big thing here.
Bilateral or two-sided therapy, like that being tested at UC San Francisco, may make the best use of the brain's ability to adapt to trauma like stroke. In stroke, an interruption in blood flow damages a part of the brain, leading to reduced motor control on one side of the body. While the damaged area of the brain can't be regrown, the brain can work around the problem and make new neural connections. Researchers hope that symmetrical exoskeleton robot will help patients make the most of this rewiring capability.
It's a serious test of the range of motion, and it was hard. Sweating every time through that process. So it wasn't easy. I think they have to go through those stressful things for the requirement. I don't think it occurs just I think you really got to work hard at it.
So moving the exoskeleton from a lab to a clinical setting is a very rewarding exercise for us, but it's also very challenging because the research lab is a very protective and well-controlled environment, where the clinical setting is exposing it to higher stress.
Looking at the robot, Iron Man sort of thing, right? Sitting in a chair and putting these exoskeleton arms on him. It's not perfect, but it's a little bit delicate, right? And I think anytime you do something like that new, it's a good issue.
It is very rewarding, not just technically, but emotionally, because you work for a decade and developing the technology, and eventually you see that this technology can affect someone's life.
As the study progresses, Rosen envisions the robotic arms in a gym-like setting, perhaps in a physical therapy clinic, where multiple sets of the therapeutic systems could be available. Patients could go to train their brain as often as they like.
Drawback of other types of therapy. If you're doing it on your own, it can be drudge work, right? I think we give up on it because of that. It's a pain in the neck, so we give up. And so if you can play a game and be at least somewhat entertaining, right? I think it makes a big difference.
So just to wrap up this video, we did experiment at UCSF with 3 groups. One group got the common practice, a human therapist is treating them. Another group did a single arm, only the disabled arm, and the third group did both arms, and we managed to show that dual arm in a symmetric mirror image fashion was superior to any other treatment that we at least tested. So that will be it. Thank you very much.